Hi, this video is in continuation to the last one on the rolling die, wherein we saw the possible number of ways of getting a particular sum when two unbiased dice are rolled. And let's revisit a couple of things from the last video. This first triangular arrangement shows all the possibilities for the sums starting from 2 to 12, right? And we also saw that for sum as 7 we had maximum number of possibilities, right, equal to 6. Another thing that we noticed was that probability of getting the sum as s is the same as probability of getting the sum as 14 minus s, right? Yet another thing that we can observe from here is, if you see, what's the average of the extreme sums? We have extreme sums as 2 and 12. So if we see the average of 2 and 12, it comes out to be 7, right? 2 plus 12 by 2. And this happened to be our vertex right here of this triangle. And coincidentally, this also happens to be the sum with maximum number of occurrences, right? Or maximum possible number of ways of getting this particular sum. Now let's move on to 3 unbiased dice. Now if you see this second figure, I have populated the sums corresponding to 3 dice, minimum sum being 3 and the maximum being 18. 3 corresponds to 3 ones on the 3 faces, 18 corresponds to 3 sixes. We also know that there are 216, which is the same as 6 cube ways of, total number of ways when we roll 3 dice. So if you see here, what's the average of the extreme sums? The average of extreme sums, which are 3 and 18, comes out to be 10.5, which surprisingly is not a natural number. So let's say if I were to construct a triangle like this, I would have had the tip or the vertex of the triangle as 10.5. Now, is that possible? It has to be the sum cannot be a decimal, right? It has to be a natural number. So we consider this 10.5 to be midway between two juxtaposing numbers, two next to next numbers, 10 and 11. So what we do is we truncate this triangle to a trapezium whose two upper vertices represent 10 and 11 as sums. At the end of the day, we are populating sums. So the intermediate sums now can be populated as a part of a trapezium. Now let's see what numbers will come in front of these sums. So let's start with 1 here in front of 3, because there is only one way of getting 3 when we get all ones. There is only one way of getting 18 when we get all sixes. Now do one thing. Second value in front of 4 should be 3. 1 plus 2, 3. Then we have 3 plus 3, 6. 6 plus 4, 10. 10 plus 5, 15. 15 plus 6, 21. Now we will not follow this trend. We had added 6 last. Now we will add 4 only. And lastly we will add 2. Right? See here again. We started with 1, added 2, added 3, 4, 5, 6. It increased till 6 increment, and then it decreased. Then we had only 4 and then 2. Basically up to 21 these numbers form triangular number series, which we will discuss later on. Triangular number series is something like, there is an increment of 1 between the differences. So henceforth there is a difference in pattern, which is attributed to the fact that there are other terms that we will get when we expand, using our functions that we saw in the previous video. So what we do now, we have 27 up to here, and 10 and 11. Since 10.5 was taken as the average of 10 and 11, we treat 11 as also having 27, and then we take a mirror image on the right hand side. So this also becomes 25, this becomes 21, 15, 10, 6, 3, and that's what we intended to get to. So this is the final representation for n is equal to 3. So when I say n is equal to 3, it means 3 dice, right? Okay, so if someone asks you what's the probability of getting a sum as 10, straight away the answer is 27 is in front of 10, 27 upon 216, right? Which is the same as probability of getting the sum as 11, right? Another interesting thing here is, if you see the sum of 3 and 18 as sums is 21, 4 plus 17 is 21, 5 plus 16 is 21, 6 plus 15 is 21, right? In other words, and you also see that probability of getting the sum as 6 is the same as probability of getting the sum as 15. Probability of getting the sum as 9 is same as probability of getting the sum as 12, which in other words means that probability of getting the sum of s is the same as probability of getting the sum as 21 minus s, in this case, in the case of 3 dice. Okay, and now another thing to note here is that since 18 and 3 averaged out to 10.5 and we truncated it to 10 and 11, probably the number of ways of getting the sum as 10 and 11 would be the highest possible when 3 dice are rolled, and that is equal to 27, right? So that will also in turn have the maximum probability or chance of coming. Now another thing, we want to know why are we getting these numbers, where are these numbers being sourced. Similarly, you know, as we dealt in the last video, we'll check it out. Now what we now need to find is, if you refer to the last video, now we need to find, let's say we are talking about probability of or maybe number of ways of getting the sum as 10. So we are looking at the coefficient of x to the power 10 in the expansion of x to the power 1 plus x to the power 2 plus x to the power 3 plus x to the power 4 plus x to the power 5 to 6 whole to the power 3 this time, corresponding to 3 dice. Last time we had 2, so we had 2 in the power. Now if you see, x is common, can be taken out common. So if you take x out, it will come out as x cubed, because 3 is the power here, right? And if I take out x cubed, it means we can as well say that we are looking for coefficient of x to the power 7 now instead of x to the power 10, because 10 minus 3 is 7, in the expansion of 1 plus x square, so on and so forth till x to the power 5 whole cube. Now we know that this expression we saw earlier can be written as 1 minus x to the power 6 whole cube into 1 minus x whole to the power minus 3, right? Okay, now we need to understand that since we are looking for coefficient of x to the power 7 this time, one thing we will do is, corresponding to this one, we can find the coefficient of x to the power 7 in the second second term's expansion. But since this power is greater than or equal to 6, x to the power 7 is greater than or equal to x to the power 6 in power, so we also need to consider other terms from the first expression. Let's see what it could be. So if I were to expand the first term, we would have something as 1 minus 3 x to the power 6 plus something something. Then this expansion would go like 1 plus 3c1x plus 4c2x square plus 5c3x cube plus so on and so forth, right? Now since we needed the coefficient of x to the power 7, so at first let's take the one corresponding to 1 from this bracket, and then x to the power 7 from the second expression. If you see in this second expression, any coefficient, let's say if we're looking for a coefficient of x to the power n, then we are talking about n plus 2cn, right? This is the coefficient. So if I am talking about x to the power 7, I am talking about 9c7, right? Now we also have x to the power 6, and I have minus 3 with it, so I can take a minus 3 into, now we already have x to the power 6, so x to the power 6 needs to be multiplied with x to get x to the power 7. So I will only need to see the coefficient of x in the second expression, which happens to be 3c1. Now if you look at the third term onwards, for the first expression the power is higher, x to the power 12 onwards, which means that we do not need to bother ourselves, because the highest power we needed was x to the power 7, and we are done. So this expression in itself gives us the total number of ways of getting the sum as 10. Now if you calculate it, it comes out to be 9c7 is nothing but 8 into 9 upon 2. This is 3 into 3, 9, and this comes out to be 27, and this is what we had over here, right? So this is very important. You need to consider the second term as well, maybe third term as well, depending on what coefficient are you looking for, which power of x's coefficient you are looking for, right? I hope you got the concept here as well. Now in the subsequent video we will look at generalizing it for any n and s. Thank you. Stay glued.